RIGEL is a blue supergiant star in the constellation of Orion. This system is located at a distance of approximately 860 light-years from the Sun. One of the most talked about and loved stars of all, the bright twinkling blue star in the bottom right corner of Orion, is a highly recognisable sight in our skies. Hi everyone, Vega here. In today's feature-length video, we're going to be talking about all things RIGEL in possibly the longest documentary ever made about this wonderful star. So let's get to it. First things first, I've always pronounced the blue star RIGEL, but you wouldn't be wrong if you pronounced it RIGEL. In the north of England we tend to use a sharper I sound than in the south or in the States, much like the country of Iran, or Iran as they say in the States. Due to its stellar wind, RIGEL's mass loss is estimated to be 10 million times that of the Sun. With an estimated age of 7 to 9 million years, RIGEL has now exhausted its core hydrogen fuel, expanded and cooled to become a supergiant. The RIGEL A star is generally the 7th brightest star in the night sky, and it is occasionally outshone by Betelgeuse, which varies over a larger range. This means RIGEL was officially designated as Beta Orionis due to the fact it was actually dimmer at the time of recording than Betelgeuse. Normally though, RIGEL is the brightest star in Orion. The RIGEL system is normally only really considered as RIGEL A, the main star, but its companions make it into a quadruple star system. The famous novel The Other Berlin Girl reminds me much of RIGEL, because the other RIGEL stars have a combined apparent magnitude of 6.7, making them collectively 1/400th as bright as RIGEL A. Two stars in the system can be seen by large telescopes, and the brighter of the two is actually a spectroscopic binary itself. This means it was discovered by the radio velocity method, much like we discover exoplanets, and that can't actually be distinguished by telescopy. The three stars, RIGEL BA, BB and C, are all large stars in their own right, blue-white main sequence stars, each 3 to 4 times as massive as the Sun. RIGEL A and its companions orbit a common centre of gravity with a period estimated to be around 24,000 years. RIGEL B's projected separation from RIGEL A is around 2,200 astronomical units. The inner stars of the triple system, BA and BB, orbit each other every 10 days, and remember these are the ones that were the spectroscopic binary, and the outer star C orbits the inner pair every 63 years. This begs an interesting question as to what potential habitable zone for RIGEL might look like. In this graphic we see my own calculations estimating that the RIGEL habitable zone extends out to as much as 1,000 astronomical units. It is widely thought the sweet spot though, or Earth-like area, could potentially be around 346.4 astronomical units, and at this distance a year length would be roughly 1,350 Earth years, but it obviously could vary greatly depending on many factors, perhaps most important of which being the light received from RIGEL has an effect on the strength of ice albedo feedback in the climate of planets. It's possible that around a blue giant, that more of the blue-white radiating light would be reflected back into space than for a star like our Sun, say. So this hypothetical planet could very well be an irradiated snowball. In the southern hemisphere, RIGEL is the first bright star of Orion visible as the constellation rises, and correspondingly it's also the first star of Orion to set in most of the northern hemisphere. Interestingly, the star is a vertex of the winter hexagon, and this is an asterism that includes Aldebaran Capella, Pollux Procyon and Sirius. It's quite an astonishing sight. It seems quite fascinating for us to consider that so many of the brightest stars in our sky lie in and around the winter hexagon, which incidentally is actually on the freeway out of the Milky Way from our perspective. The RIGEL system's spectral type is typical for late B-class stars, and its radial velocity, meaning how fast it is approaching or disappearing from our Sun, has been measured around a mean of around 21.5 km a second, meaning that RIGEL is slowly making its way away from our solar system, but it's not going anywhere anytime soon. Contrast this, of course, with some fast-moving stars with respect to the Sun, like Caprane's star, which is positively streaking away from us at 245 km a second. Or the more famous Barnard star, which is approximating our solar system, this time at minus 110 km a second, and the minus denotes that it's coming towards us. As you might expect for such a massive star, RIGEL's mass loss rate due to stellar wind is extraordinary, and about 10 million times more than the mass loss rate for the Sun. The wind is thought to have a terminal velocity of around 300 km a second, and it's estimated that RIGEL has lost as much as 3 solar masses since beginning a life as a star of around 25 solar masses, some 7 to 9 million years ago. The fellow Orion stars of Betelgeuse and Saiph lie at a similar distance from the Sun to RIGEL, although Betelgeuse is actually a runaway star. In our constellation series, we did look at what we might expect to see from a planet that was more nearby these 3 stars, and I'll link that in the card above, and don't forget to check that one out. Given that RIGEL A has exhausted its hydrogen fuel, it is a blue supergiant that has expanded and cooled and moved away from the main sequence across the upper part of the Hertzsprung-Russell diagram. When it was on the main sequence, its effective temperature would actually have been an astonishing 30,000 Kelvin. Indeed, the fraction of helium at the surface of RIGEL these days is estimated to have increased from around 26.6% when the star formed to around 32% now. RIGEL is expected to eventually end its stellar life as a Type II supernova, as you may know, and it's one of the closest known potential supernova candidates to Earth. Amazingly, if it were to actually go supernova, don't worry because we'd be safe enough, but RIGEL would be expected to have a maximum apparent magnitude of around -11. Around the same brightness as a quarter moon, or around 300 times brighter than Venus ever gets. In the end, the supernova would leave behind either a black hole or a neutron star. In the sitcom The Simpsons, Kang and Kodos identified RIGEL 7 as their home planet. Many of us know that RIGEL is a variable star, and indeed it's actually considered an Alpha Cygni type star, which unsurprisingly corresponds to the Titan star of Deneb, also known of course as Alpha Cygni, the prototype star for this kind of brightness variability. What many of us don't know though is that it shares its space with 3 other large stars in their own right. The most luminous star of all in our local 1000 light-year area, RIGEL is a star that many young stargazers look up to and wonder why they see this bright blue twinkling in the bottom right corner of Orion. Its marvel and beauty, however, does not diminish as we get older. Space has always fascinated humanity, and certain stars have served as guiding lights for explorers, sailors, and travellers throughout history. One of those stars, the beautiful RIGEL, captivates us all. RIGEL is in all probability the most popular star to make videos about on YouTube, and hopefully not to jinx this one, but RIGEL videos, it seems, always perform well. I guess there's just something about that beautiful blue tinge at the bottom right corner of Orion. I like to think of RIGEL as the mother of our local area, second largest star by mass, brightest by luminosity, and with the possible exception of Canopus, which lies somewhere in between, it has the brightest apparent magnitude of a supergiant star that we can see with our naked eyes. RIGEL stands as a class B8 1A blue supergiant in the Orion constellation, gracing our winter evenings up here in the northern hemisphere and delighting those of you in the southern hemisphere in the summer evenings. Not just a single star, but a multi-star system composed of 4 stars. Although RIGEL is relatively close to us at an estimated 860 light-years, its influence goes far beyond our solar system. Some of you may have seen our feature-length video on our Sun, and how far away it would have to be before it disappeared from our skies, and the answer is 73 light-years, at least to the naked eye. Well, prepare to be amazed, because RIGEL by contrast would still be visible to the naked eye approximately 25,000 light-years away, still boasting that key apparent magnitude of 6.5. For reference, that is approximately 1/4 of the way across our entire Milky Way galaxy, or indeed, as far as the Sagittarius A star that lies in the centre. Throughout history, RIGEL has been a vital navigational aid for Earth sailors and travellers, thanks to its prominence in the Orion constellation. But it's not going to end there. As space exploration extends beyond our solar system, because of its sheer luminance, the future RIGEL will continue to serve as a crucial waypoint for interstellar navigation. Spacecraft of the future could well be relying on RIGEL's position and proper motion to determine their location and orientation in space. As an illustrative example, the star of HD 34445, a small G-class dwarf much in the mould of our Sun, is in the direction of RIGEL, and it has a sub-Jovian planet that is located within the star's habitable zone. So one day, who knows, it may attract interstellar visitors someday. Just like driving down the motorway, we will follow signage with a larger city, or should I say star in this case, signposted, RIGEL, so we know which general direction we're headed. RIGEL, of course, belongs to a category of massive, luminous stars. Over time, this stellar beast has depleted its hydrogen fuel, and soon enough, celestially speaking at least, it will enter a phase of expansion. Despite its already frankly majestic status, RIGEL's journey has only really just begun, and it's destined to metamorphosize into a red supergiant star. But not your typical large red star, of course, like maybe Arcturus or Aldebaran. No, RIGEL has bigger plans. Its final volume will be unclear, but the chances are that it would likely be even larger than Antares or Betelgeuse. It remains indeed within the realms of possibilities that its borders could even expand to those of the mythical hypergiant stars like VY Canis Majoris or UY Scuti. Obviously, this transformation is eagerly awaited by astronomers, as it will provide crucial insights into the final stages of massive star evolution. Being one of the brightest nearby supergiants, when this happens a few million years or so from now, RIGEL will offer an exceptional opportunity to refine models and theories, if of course they're not already perfected by then, or indeed the humanity still exists, deepening our understanding of the broader universe. Of course, RIGEL is not a stationary point, and a radial velocity of 1.31 km a second, RIGEL is ever so slowly making its way away from our solar system, and will slowly dim over the coming millennia. But it's not going anywhere fast, unlike Betelgeuse of course, which is actually racing away from us at over 21 km a second. Yes, it's safe to say that the celestial mother of our local area is going to stick around and keep an eye on us from a safe distance for the foreseeable future. Indeed, RIGEL's future interactions with nearby stars, star clusters and even potential close encounters with our solar system remain intriguing prospects. When RIGEL transitions into a red supergiant, as one of the largest stars in our galaxy during this phase, indeed, the red supergiant RIGEL will increase in luminosity. The current absolute magnitude of -7.84, which is the brightness it would appear as if it were 10 parsecs, or 32.6 light years away, is testaments to its current brilliance, making it the most luminous star within 1000 light years. Although Deneb at -8.38 would actually overshadow RIGEL in luminosity, Deneb lies beyond the 1000 light year mark, so RIGEL, therefore, earns its distinction as an exceptionally radiant celestial object. Viewers of this channel will likely be aware that RIGEL forms an integral part of the winter hexagon, a dazzling star pattern that captivates observers during the cold midwinter nights. So it seems likely that in the next few million years, RIGEL is projected to evolve into a red supergiant, initiating its path towards the final phases of its stellar journey. This red hypergiant phase is estimated to last between 100,000 and 500,000 years. After this, the probability is that a gigantic supernova explosion will leave behind an almost infinitely dense degenerate object, which some might call a black hole. Wherever we are at the time, the supernova will be so bright that it promises to be a momentous spectacle, even if it will be unfolding over cosmic timescales, and definitely not within our lifetimes. Sorry guys, RIGEL is burning fast, but it's still not ready to go boom just yet, unlike its counterparts of Antares or Betelgeuse. In today's graphic, we imagine the stages that RIGEL will pass through as it ages. The brightnesses are only speculative though, as we don't really know how bright things will become. The first stage, RIGEL expands into a red supergiant, increasing its luminosity, but definitely turning red in colour. The star slowly dims then as it moves away from us over the next 500,000 years, until eventually we see the supernova, a huge celestial event in our night skies, which will by then likely have been preceded by both Betelgeuse and Antares, as well as possibly the star of Canopus, although this depends on which stage of the blue loop the star finds itself in. RIGEL is an emblematic star in the Orion constellation. Its significance in the night sky would stretch as far as 25,000 light years before it disappeared from naked eye view. RIGEL is likely to be used for navigation in space in the future and will eventually swell into one of the very largest stars in the entire galaxy. As RIGEL embarks on this journey, it does open a window for humanity to witness the grand finale of a massive star's life. The discoveries that await us as we observe and study RIGEL's evolution as humanity advances over the coming millennia will undoubtedly enrich our understanding of the cosmos, and indeed, our own place within it. In this next video, what we're going to do is we're going to compare RIGEL to the Sun and move it to different places and imagine what the star might be like when seen from different vantage points. So let's carry on. In our first graphic, what we're going to do is we're going to actually remove the Sun from our solar system. We're going to pair it with RIGEL at 100 light years distance. Now let's see how that plays out. Here we can see 100 light years distance, the Sun on its way out. 100 light years is some 6 million astronomical units. It's just an astonishing distance. RIGEL is currently the 7th brightest star in our skies, if we don't include the Sun, but now it gets brighter and brighter as it moves towards us and the Sun moves away.
RIGEL is actually a multiple system of 4 stars, but for the purposes of this video, we're only going to be talking about RIGEL A, which is the one that most people think of as the star itself. RIGEL now at 100 light years is minus 5.58, by far and away the brightest star in our skies, much brighter than even the planet Venus, and the Sun, as we can see, has disappeared completely from view. At an apparent magnitude of 7.17, it's no longer visible to the naked eye. So RIGEL, now the brightest star in our sky. Okay, so what we should do then is change the parameters. What we're going to do now is we're going to move ourselves out to the Jupiter's beautiful moon of Callisto. And we're going to move the 2 stars to one triple star system with Sirius at some 9 light years. This is because Sirius is currently the brightest star in our sky. Let's see how that plays out. So at some 570,000 astronomical units, we can see Sirius's magnitude is minus 1.46 and is the brightest star in our sky as the Sun fades away. RIGEL now getting bigger and bigger as we can see. The Sun this time doesn't disappear, its apparent magnitude 1.84 leaves it a bright star in our sky but not even in the top 10 list. Whereas RIGEL, now look at it, it's becoming brighter and brighter, a variable star itself, so it could even become brighter than this. With its apparent magnitude of minus 10.94, it's as bright as a quarter moon. What a magnificent star it is, and the pure power is just unbelievable. So what we're going to have to do is change the parameters again. This time, let's go back to Earth. And what we're going to do is we're going to move RIGEL and the Sun just to 1 light year's distance now. Let's see how that plays out. Don't forget that 1 light years is still a huge distance of 63,000 astronomical units. Here we see depicted the Grand Canyon in Nevada on a day with no sun. In fact, there is a sun, and there it is, but it's minus 2.82. It's a very, very bright star in the sky, but still wouldn't be outshining Venus. Well, it would because there's no sun to reflect it, but as you can see, RIGEL is just a completely different category of star. At 1 light year's distance and a minus 15.58 magnitude, it's now as bright almost as the full moon. It might make you wonder what the habitable zone of RIGEL, would that make the Grand Canyon really habitable now we've lost the sun? The answer is no, because although RIGEL is such a powerful star that its habitable zone reaches at 650 astronomical units, 1 light year is just an astonishing distance that even the star at RIGEL's category cannot warm up for us. So we can see that RIGEL far outshines the Sun at 1 light year's distance. So what we're going to have to do is we're going to have to change the parameters. We're going to put the Sun back in the centre of our solar system, and RIGEL, primarily burning helium at the current point of its life cycle, at 367 astronomical units from us. The reason being is this is where the apparent magnitude will be roughly the same as the Sun. Let's see how that plays out over the beautiful city of Liverpool. RIGEL, of course, is actually probably the most powerful star within 1,000 light years of us, and some might think of it as the mother of our local area in the galaxy, but at least I like to think of it that way. Here we see the beautiful sun rising over the city of Liverpool and the library buildings and the port. At some 0.006 light years from us, or 367 astronomical units, here we see RIGEL rising, the same brightness as our own Sun at minus 26.74 magnitudes. Imagine having twin stars like this. RIGEL being, the reason you can see a disk there is because the disk of RIGEL would be actually a lot smaller, obviously, than the Sun, some 367 times smaller. So it may be that we could see the faint disk of RIGEL through the clouds, whereas the Sun is just too close. In fact, there is actually a mountain named after RIGEL in Antarctica. Interestingly, RIGEL is actually classified as Beta Orionis, as we know. The reason being is that Alpha Orionis, Betelgeuse, is actually a very variable star, and it may be that when it was named, RIGEL, although generally brighter than Betelgeuse, was actually not as bright at that point in time. Anyway, let's move on then and see what else we can do. Now, bear with me a minute because this is going to be a little bit difficult to explain. What we're going to do now is we're actually going to remove RIGEL from the equation and imagine it was the centre of our solar system, although it won't be depicted in the next graphic. Now, to get the Sun to the same brightness as RIGEL would be in the centre of our solar system, what we actually have to do is move it to the distance of the Moon. So imagine planet Earth with the Sun at the Moon. That's literally how bright RIGEL would be at that distance, and let's see how that plays out. Of course, the BAL1A class of luminous supergiant is just a different category of the star to the Sun. The Sun is just a mere T-type yellow dwarf. But look at this, over Mount Everest in Nepal. The Earth just wouldn't be able to take it. The Sun at almost minus 40 magnitudes, it would just become vaporized, and much of the Earth would become vapor and water. Just unbelievable how powerful RIGEL is. And again, just to remind you, that's the Sun at the Moon, which is equivalent to what RIGEL would be at the centre of our solar system. I don't think we'd be surviving much longer. Mount Everest itself may survive, but certainly all the snow and all the liquids around would just be vaporized instantly.
RIGEL in the bottom right corner and Betelgeuse in the top left. Two of the most well-known stars of all, Alpha and Beta Orionis, shine brightly, holding their own proudly in our skies. But which one of them could win in a battle for supremacy of the Orion constellation? Those of you that are familiar with the stars will know that the constellation of Orion contains both of these giant stars. Betelgeuse here on the top left, also known as Alpha Orionis, and RIGEL on the right, also known as Beta Orionis. So let's have a look at where these stars rank on the main sequence. We can see Betelgeuse top right here, not in the mainstream, and indeed not even in the regular class of giants, an M-class star, whereas RIGEL is classified as a B-class supergiant. Seeing also the magnitudes, RIGEL shines at an absolute magnitude of minus 7.8, whereas Betelgeuse, as it's a variable star, can vary somewhat between minus 5.5 and indeed as high as minus 7.8, just like RIGEL itself. In terms of mass, Betelgeuse contains 11.6 plus or minus 5 solar masses, so it's a gigantic star. RIGEL has 21 plus or minus 3 solar masses, so an even bigger star, and both are huge, powerful, and certainly in the supergiant category. Let's have a look at the actual sizes of the stars. We can see here in this diagram right at the bottom a little speck of dust, which is in fact our Sun, a typical G-class main sequence star, through Sirius and Pollux, which is also known as a subgiant, Arcturus of course, Alpha Boötes. Then here we are, here's RIGEL, and you can see already that the volume Betelgeuse is far in excess in any of those, the red star here being Betelgeuse. If we were in our own solar system, it would actually cover all the way out to the orbit of Jupiter. RIGEL on the other hand would not quite cover the orbit of Mercury, about halfway out, but still a large star nonetheless. So how do they rank in our skies then? Let's have a look at the brightest objects in our skies, the Sun, Moon, Venus, Jupiter, Mars and Mercury, all planets of course, until we get to Sirius, the brightest star in the sky. Through Canopus, Saturn, of course another planet, Alpha Centauri, Arcturus, Vega, and then eventually here we are at the 13th brightest object, or 6th most luminous star in our sky, Betelgeuse. We continue through Capella, and interestingly the first galaxy we find is the Large Magellanic Cloud, which can be seen in the southern hemisphere, unfortunately for those of us that live in the north. And then finally RIGEL at the 8th brightest star, or the 16th brightest object, with a plus 0.17 magnitude, still an extremely bright star indeed. Interestingly, Betelgeuse has also been dimming fairly recently, although it seems to be back on track for now. Betelgeuse being a variable star would have dipped somewhat off this list until recently, although lesser known RIGEL itself is actually a variable as well. It does change plus or minus 0.13 magnitudes, so sometimes almost into the negatives at its very brightest, but not on the same degrees of variability as Betelgeuse. The distance out to Betelgeuse is 700 light years and RIGEL is estimated at 860. This means RIGEL does start with a slight disadvantage, although it's a smaller star by volume. We don't know the exact distance and it could be even as far as 940 light years. Betelgeuse with the larger disk makes it easier to measure and both sit reasonably similar distances from the Sun. Now what we're going to do is we're going to imagine that both stars were at 1 light year's distance, some 63,000 astronomical units from us. What would Betelgeuse and RIGEL be like? Obviously they're both very luminous stars. Betelgeuse at its maximum, remember, is almost 230,000 times brighter than the Sun. RIGEL 120,000 times brighter than the Sun, so we're actually talking about a completely different class of star. What is fascinating here is that if they were at 1 light year's distance, the Sun would remain the brightest object in our skies, but both Betelgeuse and RIGEL would become brighter than the Moon itself, in fact some 16 times brighter, so at their most luminous, extremely bright objects indeed. Let's have a look at how that might look in our skies. First of all, you might wonder if we'd be able to see a discernible disk. In this graphic, if the Sun was in our sky, we can see that the answer is yes, for certain with Betelgeuse at least. Betelgeuse is a star that's much larger than the Sun, so even in our sky the Sun would only be 70 times larger, so there'd definitely be a discernible disk for us to see. RIGEL perhaps less so, a possibly discernible disk with binoculars, although I wouldn't advise looking at the stars of this magnitude with binoculars of course. We may see a disk, but certainly showing us a bright star of the class that we don't have in our sky at this present time. So we wonder what they might look like if we went to the pyramids of Giza. Here we see the beautiful Sphinx and the Khafre pyramid in the background, some 36 meters of height. What would happen in midday? This is something like what we might see in our sky. So you can see here on the left the blue-white supergiant RIGEL, and in the middle here the reddish tone of the red supergiant that's Betelgeuse, shining brightly, way outshining the moon when it meets our sky. Even in daylight, these two stars would actually increase the brightness of our day on Earth. They would be that powerful at 1 light year's distance. But what about if it were dark? Here we see Edinburgh, capital of Scotland of course, the beautiful castle there in the moonlight. And here we imagine RIGEL and Betelgeuse. They're clearly much brighter. Both objects 16 times brighter than the moon of course. We imagine a clearly blue and slightly red star in the sky, much brighter than the moon, so almost providing daylight at night. That's how astonishingly powerful these stars are. So overall then, as this is a battle of course for the supremacy of the Orion constellation, RIGEL with its larger mass and altogether more powerful star, and certainly in the future it will become even bigger as well, versus Betelgeuse, of course a red supergiant and an M-class powerhouse. There is however a question mark for me with Betelgeuse, as it does vary quite a lot in luminosity, and at its dimmest is substantially less bright than RIGEL. Betelgeuse certainly isn't the largest supergiant in our Milky Way, and those titles might fall to the likes of VY Canis Majoris, Stephenson 218 and Mu Cephei. Betelgeuse is also much further towards the end of its life cycle than RIGEL, so I think overall I'm going to give the title to RIGEL, but perhaps only on penalty kicks. A very close tie, but overall because RIGEL is the most massive of the two, it does make a more powerful star. Let's be thankful we don't have to really choose between these two superstars in the near and indeed distant future. Thanks for watching and consider subscribing if you haven't already. If you'd like to support the channel further, you could consider buying me a coffee and I'll link this in the description. Thanks to those of you who've already done so, and if you want any videos or subjects you'd like to see brought to life, don't forget to let me know in the comments below, and perhaps next week your idea may just show up. Take good care of yourselves and look after your friends and family well, and I'll see you on the next one.